Hello my scholars, you're welcome to my school YouTube channel. My name is Emmanuel and in today's video we'll be treating acid, bases and salt part 2. Please don't go anywhere, stick around and we'll be right back. You're welcome back. Like I said earlier on, today we'll be looking at acid, bases and salt part 2. Now let's get down to it. Basicity of acids. All acids will yield hydrogen ion when dissolved in aqueous solutions. These hydrogen ions can be replaced by metallic ions. However, the number of replaceable hydrogen ions, that's hydrogen ion H positive, in one molecule of an acid is what we refer to as basicity of an acid. In other words, when acids that have hydrogen ion, remember that what qualifies in one of the definitions we gave about acid is that when they dissolve, substances that dissolve in water or in aqueous solution to produce hydrogen ion as the only positive ion or an anion in this present is what we refer to as basis. Now, the amount or the number of hydrogen ion that can be replaced in that acid is what we actually refer to as the basicity of an acid. So, we say the number of replaceable hydrogen ions H plus in one molecule of an acid is what we refer to as basicity of an acid. Let's move on to the next slide. Okay, we have the basicity of some common acids here. We have HCl here, okay. HCl, if you dissociate this, in solution, you are going to have H positive, okay. You are going to have H positive and then you have Cl negative. You have hydrogen ion that is produced and then you have anion that is also what produced. The H here and then the Cl will split. Okay, that's what we mean by dissociate. Okay, so the number of hydrogen we have here for this HCl is actually one that can be replaced. What we mean by replacing is that if a salt is coming, let's say sodium, a metal is coming in for instance to react with this, okay, sodium reacts with this and then displaces this hydrogen and comes in here. Of course, this becomes NaCl minus. So it is only one hydrogen here that can be replaced by a metal when it comes in here to form salt. So to this we say the basicity is 1, or we say it is monobasic. Either you say it is monobasic or the basicity is 1. The same thing happens similarly. We have HNO3. If HNO3 dissociates when dissolved in solution, you're going to have H plus, then we have NO3 minus. So one hydrogen is what can be replaced here by metal when it comes into form salt. So we say basicity of HNO3, or which is nitric acid, is also 1 or monobasic. So we have H2SO4. Now if H2SO4 dissociates here, okay, we are going to have hydrogen, but because we have both of hydrogen there, so we have 2 ion here and then we have plus SO4 2 minus. 2 minus because this is the radical of the sulfate, this is the charge, so it means 2 electrons are here, 2 charges here, so it means 2 positively charged ions to also what to be able to form that. So when H2SO4 dissociates in aqueous solution, we are going to have 2 number of hydrogen ions that will be split, that will be dissociated there. So we say the basicity of H2SO4 or sulfuric acid is 2, or we call it dibasic. Look at what happens here, H2CO3. Similarly, H2CO3, although this is a weak acid, but you discover that if it dissociates, we have 2 hydrogen here, so we are going to have 2 H plus. Okay, we have 2 H plus here, we have CO3, will be left here 2 minus. Okay, so which means we have 2 plus 2, that so we have 2 of this. So the basicity of this acid is also 2, or dibasic. H3PO4, okay, that's for phosphoric acid, we have 3 of that. When you dissociate that, we have 3 H plus and then we have PO4 3 minus also. 3 H plus, okay, plus PO4 3 minus. You can see that. So we have 3 number of hydrogen ion that can be replaced in this acid to form that. So the basicity of H3PO4 is actually what? Is 3, or we say it is what? Tri-basic. Let's move on to the next slide. although ethanoic acid, okay, that is CH3COOH, remember it has its source for what? From vinegar. Okay, when we talked about organic and inorganic acids. Okay, so although ethanoic acid has 4 hydrogen atoms per molecule of acid, only one of the 4 hydrogen atom is actually replaceable by a what? By a metal. Ethanoic acid is therefore said to be monobasic, or the basicity is actually what? See what we mean? This is CH3COOH. Okay, if you dissociate that, you are going to have CH3COO minus, then plus what? H plus. So when a sodium or a potassium a metal comes in here to react with this hydrogen is the only one that is replaceable. You cannot replace this, okay, because it's a weak acid. So when you displace this one is off, and then we have this. So by the time you have that, we'll be having 1 hydrogen is what actually can be what? That can be dissociated, that can be removed from there. So that can be replaced by a metal when it is reacted by whether an alkali or a base, okay, to form that. So only 1 hydrogen can be replaced there. So we say ethanoic acid is therefore said to be monobasic. So for objective purposes, please take notes. In objective questions, such questions are asked. In fact, they have been repeated over and over again. Ethanoic acid has a basis to be what? Option A, 1, 2, 3, 4. Sometimes we could look at it. Some students get confused because they feel we have CH3CO, so 3H plus 1 making 4. So and then say, oh, it is 4 because there are 4 hydrogen atoms there. No, it is only 1 hydrogen, the last one, that can be replaced by a metal. So we have CH3COO minus plus H plus. So 1 hydrogen is that. So the basicity of ethanoic acid or CH3COOH is actually 1 or monobasic. Let's move on to the next slide now. Now we have looked at classification of acids based on sources, which is organic or inorganic. We have looked at classification also based on, just like we just saw now, okay, based on the amount of acid, okay, that can be placed. So the second classification of acid now is based on dissociation. Remember, we said there are 3 classifications. First, based on sources. Second, based on dissociation. And thirdly, based, which is the strength, okay. And thirdly, we talk about whether they are concentrated or whether they are weak acids. So let's look at strong acids now. When you dissociate, now we are talking about how do they dissolve. Is it partially or completely? Those acids that dissolve partially, completely, when they are reacted with aqueous solution or with water, are said to be what? Are said to be strong acids. So strong acids will ionize completely in water to give hydrogen ions and anions. When you dissolve them in water, strong acid will dissociate completely. Okay, there will be no hydrogen that is left. All the hydrogen that is there will be separated. Okay, will be separated, will be dissolved, while the other anion will also be what? Be separated. All the hydrogen will be separated. That's how you can know, or you can differentiate between strong acid. Then look at this. There is complete ionization of hydrogen ion in these acids. The concentration of hydrogen ions in this point is very high in strong acids. So strong acids are acids that dissociate completely or ionize completely when dissolved in water. Let's move on to the next slide now. Examples of strong acid, we have hydrochloric acid, which is HCl. If you dissociate this, we have H plus, then plus what? Cl minus. So this is your anion, this is your hydrogen ion. Now, all the hydrogen that is in this acid are dissociated completely and separated from this. So we can say hydrochloric acid is a strong acid because all the hydrogen that is in that acid are actually separated, are dissolved completely in solution. Another example is SO4 2-. Of course, that is ionic. So we have sulfuric acid, or we say tetraoxosulfate 6 acid. So we have tetraoxosulfate acid, which is H2SO4. If we dissociate, we have 2 hydrogen, of course, like we did before, hydrogen ion plus SO4 2-. Okay, this is the anion. This actually is the hydrogen ion. So we have all the 2 hydrogen that are in that acid formula actually what? Are dissolved in the. So you see them separated off like that. So we have SO4 2-, and then we have what? 2 hydrogen ion. Then the third one is triazonitrate 5 acid, HNO3, or what we call nitric acid. So whether you call it as nitric acid or you call it nitric acid, we are saying the same. That's the trivial name, okay? So if we dissociate HNO3, we have H separated, and then H plus, and then we have NO3 minus as well. So in other words, we are saying all the hydrogen that are in this formula, you can see they what? They are separated from the other one. So these are examples of strong acids. Let's move on to the next slide now. On the other hand, weak acids are only partially ionized in water. Remember, strong acids ionizes completely when dissolved in water. But for weak acids, they are only partially ionized in water. There is incomplete ionization of hydrogen ions in these weak acids, okay, unlike the strong acids. So the concentration of hydrogen ion here, because they are weak, definitely will be very low. In strong acids, the concentration of hydrogen ions are very high, but in this case it's very high, but in this case now the concentration of hydrogen ion is very, very low. So you can be able to what? Place side by side, juxtapose between strong acids and weak acids. So in terms of the strength, in terms of dissociation when dissolved in strong acid, when dissolved in aqueous solution or in water, strong acid will dissociate or will ionize completely, while weak acid will ionize partially. Let's look at examples of weak acids. Ethanoic acid, remember we said the basicity of ethanoic acid is actually 1 monobasic. So if you dissociate this, so all these 4 hydrogen, we have 3 hydrogen here, atom plus 1 making 4, okay? If it were a strong acid, all this hydrogen would be dissociated. So you just have hydrogen on one side, but here if you dissociate this, you are going to have CH3, COO minus, then here it's only this hydrogen that is replaceable, okay? That will be dissociated when it dissolves in water. So you still have CH3COO minus, then you have H what positive. So only this hydrogen will be dissociated, not all. So since it is not all the hydrogen that is dissolved, we say that is a partial ionization or partial dissociation. The same thing is what will happen with thiazocarbonate 4 acid, that's H2CO3. Of course, this is a weak acid. Everything will not get dissolved, okay, when dissociated in aqueous solution. We have tetraoxophosphate 5 acid, that's H3PO4. Although the basicity is high, but they are still weak acid. So H3CO3, the basicity of this is 2, basicity of this is 3, okay, it's tribasic, dibasic here, but when they dissociate, they don't dissociate completely in aqueous solution. So in that regard, we say they are weak acid. The same thing happens to triazosulfate 4 acid, which is H2SO3. Of course, that's different from H2SO4. H2SO4 is a strong acid. This is a weak. Then we have ethanoic acid that has only 0.4% ionization in water. Only 0.4% ionization in water. So you can see CH3CO, we have H plus, which is this, and then we have CH3COO minus. So all of these are examples of weak acid. But don't mistake the strength of an acid with the basicity of an acid, though they are interwoven, but they are two different. Let's move on to the next slide now. Now, classification based on concentration. This is the last classification of acids, okay? We have talked about classification based on sources, that's whether they are organic or they are inorganic. We have looked at classifications based on their dissociation, whether they are strong acids or weak acids. The third type of classification is classifications based on concentration, okay? We have been able to tabulate to show the difference between the concentrated acid and dilute acid. One major difference between the two of them is in the composition, the amount of water that is in concentrated acid and the amount of water that is actually in diluted acid. Concentrated acid actually contains a high amount of acid and small amount of water. That's why we say it is concentrated, okay? While dilute acid contains a high amount of water and a small amount of acid. For in this case now, you can say we have you have 95% volume per volume, okay, HCl, right? This means that you have 95 ml of acid, then the remaining 5% is for water. So this is a concentrated acid. Then we can have let's say we have 2% volume by volume HNO3, okay? So what this means is that you have 2 mil or 2 cm cube of acid, while you have 98 of what? Of HNO3. So you can see that the amount of water here is more. 2 of acid, 98 of water. But in this case, we have 95 of acid and 5 of what? Of water. So more acid here, amount of water here, of acid here, while here we have more amount of what? Of water in this place. So this is a concentrated acid, while this is a diluted acid. Let's look at their level of reactivity. Highly reactive due to what? To the high concentration of acid molecules, and a fast reaction rate will occur here because they are highly reactive. That's why you discover that when you introduce a concentrated acid on a substance, in fact, it can even burn, like sulfuric acid, for instance. Okay, H2SO4 is a very strong acid. Okay, that is if the concentrated form. That's why you see them when you open them up in the jar, in the bottle, reagent bottle in which they are gotten from the amber bottle. You can see effervescence, you can see some gases involved. You have not done anything, just to open the distance. That shows how concentrated the amount of what? Of acid that you have there. So they are highly reactive due to the high concentration, while diluted acid are less reactive than concentrated acid. Not that they are not reactive, but they are less when you compare them with what? Concentrated acid. The third one is their corrosiveness. When we talk about corrosiveness, you can see that concentrated acids are extremely corrosive and can cause severe harm. Both of them are acids, and we say, look at this, a diluted acid, they are less corrosive than concentrated acid, but still hazardous. Don't forget, it does not mean that dilute acids are not also corrosive, but when you compare them, you juxtapose them side by side with concentrated acid, we see that they are less corrosive when compared to this. Then level of pH, concentrated acid are very low pH value, while diluted acid have what? Higher pH value than concentrated acid. As you move away from, as you move towards the what? The neutrality, the neutral point, which is 7 on the pH scale, you are tending towards what? The weak what? Acid, the diluted acid. Okay, when we begin to talk about pH, alkalinity and acidity, okay, we will talk more about the pH of acids, whether they are concentrated or whether they are diluted, or strong acid or weak acid. Then their uses in industries. Concentrated acid find applications, okay, like industrial applications like metal cleaning, okay, like HCl, for instance, can be used in cleaning of metal when there is rust, okay, a surface of metal that has been rust. If you get HCl, okay, you use it or this, and then you wipe the surface, the rust will be taken care of. Oil purification and chemical manufacturing. Okay, then in diluted acid we have the application in laboratory analysis. You want to analyze, you want to characterize whether qualitative or quantitative analysis will need what? This diluted acid. Okay, cleaning also, and then student experiments due to their what? Lower risk. Students can handle this, especially for instance we talk about 0.05 mil, okay, of or molarity. Let's say 0.005 mole per dm cube of HCl is not as strong as having 95%, okay, of HCl. So the students can handle this easily, but these ones must be under, okay, supervision of the teacher. So these are the differences between the concentrated acid and what? Diluted acid. Let's move on to the next slide now. Okay, let's look at the physical properties now of acids. Usually when we are talking about properties of substances in chemistry, we look at it from the physical aspect, and then we look at it from the chemical aspect. Physical aspect, what you can see with your eyes, the changes, the difference, that when you see them, you can identify them. For instance, we'll be talking about the changes that occur in color. Okay, those are physical. We talk about the taste. For those ones you can taste. Not all chemicals can be tasted. Okay, that can be, you know, can have acid. You can get to your tongue. Okay, without hurting you. But just talking generally about them. So those that are, you can look at the taste. You look at the change in color. You look at the odor. You look at the smell. Okay, and when you are smelling in the lab, you don't put it close to your nose directly. No. You put it far away, and then you can just use your hand, you know, to make it reach up to the what? To your nose, to see if the smell is there. You can identify the smell. So how do we identify acids when we see them? How do you identify them? You have a colorless substance, HCl for instance, that is colorless. You have it in a jar, and then you have water. How do you differentiate them from each other? Or you have a solution of salt. The number one, the first physical property is that what? Dilute acids have sour taste. Dilute acids, in fact, I would want to say organic acids have sour taste. Don't get HCl. Don't forget, we have talked about organic acids and inorganic. Okay, organic acids have their origins, their sources, okay, from natural products, from plants, from animals, like your ascorbic acid, which is vitamin C, okay, amino acids. We talked about lemon, which is lactic acid. We talked about citric acid. We talked about ethanoic acid, and so on and so forth. So if you take them, for instance, how do you taste this? If you get an unripe mango, okay, and then you take a bite, what happens? You feel the sour taste, okay? It's because of the presence of the acid here in the, and then you get a fruit like cherry, like berry that are unripened yet, like pineapples that are not ripened yet, okay? That are not matured fully, okay? If you taste them, you feel the sour taste, which is as a result of acid. So that's how you can be able to identify if it's an acid or not. The second physical property of an acid is that what? Acids turn litmus red. Acids turn litmus red. Some textbooks will tell you acid turns blue litmus red. But whether it is red litmus you are using or blue litmus you are using, the color must be red. So if you dip a blue litmus into an acidic solution, the blue litmus paper will change to red color. And if it is a red litmus paper you dip into an acidic solution, the color still remains red. Okay, so that's why we say acids turn litmus red. So whether if you want to say attitude that blue acid turns blue litmus red, you are correct. Or you want to say acid turns litmus red, the color red still remains the same. The third one says concentrated forms of strong acids are corrosive. Yes, those ones that are concentrated, we have seen concentrated that you have a large amount of acid in them, we say they actually are corrosive. And then the fourth one is actually that the pH of an acid solution is less than 7. Once it's above 7, it is no longer acidic, it becomes basic. Let's move on to the next slide now. Take note of this, that when preparing a dilute solution of acid, always add concentrated acid to water. Never add water to concentrated H2SO4 or sulfuric acid, because the hot acid solution may splatter onto your face and body and cause serious burns. So it's advisable when you want to dilute an acid, don't get a concentrated acid and then you begin to pour water inside. It's going to be disastrous. So what you need to do is, for instance, let's say you want to dilute to have 50% HCl, for instance. That means we want to have 50 volume of acid, then 50 volume of water. So you can start by what? By having, maybe you just measure out, let's say 50, yes, of the acid, 50 ml of the acid. Once you measure that, you have that in your measuring cylinder or in your reaction bottle, then you will now get 50 ml. Of course, you have a measuring cylinder. You want to add another 50. So don't add the water of 50 and then you begin to add this. You can just have, let's say you have 30, okay, or you say 30 cm cube or 40 ml of water. You have it ready, and then you transfer your acid gently through the wall of that container. Once it gets in, it begins to dilute until once everything is there already, what you have there is a diluted solution. So you can now add up maybe the remaining 10 or what is left to be able to what? To make up to the mark of this. So that will be 50-50 of that. So never make the mistake of adding water into concentrated acid, but rather add acid into what? Into water. Now we have come to the end of this preview. If you want to have access to the full video, feel free to click on the link in the description below that takes you to my school website. There you'll be able to have access to the full video. And in the full video, we'll be talking about the chemical properties of acids. We'll be looking at alkalinity and acidity. We'll be looking at the pH scale. We'll be looking at indicators. We'll be looking at calculations of pH and so on on and so forth. I believe you enjoyed this content. If yes, please don't forget to click on the like button, hit the subscribe button, and finally tap on the notification bell to keep you informed once we upload our next video.